We need to draw a cam profile operating at a knife edge follower. What does it mean by knife edge follower? It means just a point contact. Okay, so in the last class we discussed about the cams and the types of the followers. So this one is just like a point contact with the cam. Having a lift of h 30 mm. What does it mean by lift? It means it's the maximum amount of follower to move up. Let's say it's a baseline, it's a benchmark, and then from here it will go maximum amount of up and down and perform the other functions. The maximum is the h30. The cam raises the follower with a simple harmonic motion. Do you know what is a simple harmonic motion? SMH. The different forms of motion. Okay, so in the simple harmonic motion is like this. When we draw it, you can have a look. For 150 of the rotation followed by the period of, so 150 degrees, there is a simple harmonic motion. It will move it up according to the simple harmonic motion. And then for the 60 degree is dwell. What was dwell? Period was no. Yeah, so the radius, because we are going to draw the radial cam, so what is going to happen? The radius is not going to change, the follower will stay there. Not moving up, not going down. The follower descent, and then it will go down for the next 100-degree rotation of the cam with the uniform velocity. So one was a simple harmonic motion and other one was the simple uniform velocity. So for that we need to take the references separately, because simple harmonic motion is like if you have a circle and you draw a point, and that point, okay, if you roll the circle on the flat line, straight line, so whatever the circle dot will trace, that's a simple harmonic motion. Okay, so we take the references of the circle. I'll draw it shortly and you have it. And in the uniform velocity, what happened in the uniform velocity? It's a constant velocity, somehow constant velocity. So it's the same value of it. So the follower, these are the velocities of the followers. Okay, so the follower will move with the uniform velocity. One time when it is the follower simple raises, when it is going up, it follows the simple harmonic motion. Then there is a dwell period, and when it's going down, it follows the uniform velocity. The cam rotates uniform at 150 RPM and has a least radius of 20 mm. So what is the least radius? It's a minimum radius that the cam can be drawn. So we need to put the cam into it. We'll start with this radius. What will be the, okay, then there are some formulas which you can see it over there. So what we'll do is we just write it over here. The input data h equal to 30 mm. Okay, RPM is 120 RPM. Okay, the least radius is 20 mm. So we are going to do 3 cases. This is the case number 1. Okay. Then we have a phi when going up 150 degree. Then there is a dwell which is 60 degrees. Then it's going down or descent. It's 100 degrees. And if you want to find out the rest of the angle, can we find out the rest of the angle? So we say 360 degrees minus phi A minus delta 1 minus phi D. So you get the rest of the, you don't need to calculate it, but just to, so there are 2 dwells in it. Rise, dwell, then go up, dwell, and then the circle will keep on going. We need to draw a reference diagram. That reference diagram is called displacement diagram. Okay, so you can see the printout I gave you just to save your time, because in the exam you have to draw it in 16 minutes. Okay, here you can take like 2 hours. So just to get it in 16 minutes, I draw the displacement diagram over here. How the displacement diagram is drawn? Depending upon what we want to make. Okay, so the displacement diagram can have the equal intervals or non-equal intervals. But for the sake of the practice, make sure that every time you draw the displacement diagram with equal intervals. Okay, so how much is the height of this? This height is equal to h, which is in this case how much? 30. Okay, and then we draw it with the equal spaces. Let's say this is I think this much is enough. If we need it, we'll make more. Then, because it says it's a simple harmonic motion is involved, so we need to have an external reference to take the simple harmonic motion. Okay, so for that we can draw a circle, semicircle over here. Okay, we can draw this semicircle over here. On this, we have divisions, number of divisions. We are going to have the number of divisions same on the cam profile. Okay, the more number of divisions, the more smoother points you get it. Okay, less number of divisions, less number. So in the book they have 6 divisions. We'll try to follow the 6 divisions so that we can have. Okay, we come back to it. This displacement diagram. And we'll come back to this. Okay. So first we draw this minimum radius. So how much it is? 20. It's a radius. You should know the difference between the diameter and the radius. So we draw okay. We go up and this is our follower. So it says knife edge, so we just draw the point contact. Okay. Then we have this 150 degrees. So roughly like, I'll draw it roughly, but you have to draw it exactly 150 degree. Okay. So 90 over here, so 150 is somewhat over here. Okay. Then we have delta 1, which is 60 degrees, so something like this, 60 degrees. And then we have 100 degree, so 90 is exactly like this, 100 would be something. So this one, phi A, delta 1, phi D, delta 2. Okay, we have not done anything, we just draw the minimum radius RC, which in this case is 20, and draw this. Understandable? Make sense? Okay, now we have to divide it. We need to divide this into 6 equal angles. Okay, you can do it with the compass, you can do it with the protractor. It's up to you the way you want to divide it. And this labeling is very important. So the labels over here are the key, because otherwise we cannot transfer the points from the displacement diagram to the cam profile. Or even if you transfer it, I cannot review it, I cannot check it if you have transferred the right point. So 1, 0, 1, 2, 3, 4, 5, and 6. Okay. So the first condition, when it is going to arise, this one is basically simple harmonic motion. For the simple harmonic motion, we need to take the reference from the circle. That's why we have a circle over here. So because we divided 6, so over here we have to divide it 6 as well. 0, 1, 2, 3, 4, 5, 6. And you have to label it as well, that from here to here, this is rising. Okay? Understandable? Okay, since we have 6 division over here, 6 division over here, we have to divide the circle for simple harmonic motion for the 6th division. So let me divide it. You have to divide it precisely according to the angles. 0, 1, 2, 3, 4, 5, and 6. Okay? Then we need to take reference. We need to take a reference for each point. So 0 with 0, so this is our first point. Okay. 1 with 1, so all you need to do is to take the reference over here. So this is our second point. Okay. 2 with 2, third point. This is 1 and 1, so we call it 1 prime. 2 and 2, 2 prime, because it's a new point. We get it. Understandable? 3, we take the reference to the 3 and 3 prime. 4, 4 prime, 5, 5 prime, and then 6. You don't need to join these lines because we are interested in the height of each of it, okay? But just to make sure that you know how the simple harmonic motion would look like, this red color curve is basically representing, so you very easily draw simple harmonic. Okay, understandable? Any question? Why you choose? Yeah, it's up to you. The division is in your hand. You can choose 8, you can choose 9, you can choose 10. The more divisions, the more point. But if you have more point, then you need to spend more time to transfer it. So when I give you the homework, you can choose like 20 points. But when you solve it in the assessment, then probably 8 points, 6 points are good enough. Okay? Now we need to transfer those from there to here. So first thing first, what we need to do is we need to extend these lines. Okay? So for the line, you need minimum 2 points to extend the line, to extend the ray. Okay? So the first point is this center point, and the next point is this point. All we need to do is to join this point, passing through the 1, join this, starting from the center, passing through the point 2, passing through the center, 3, 4, 5, and 6. Okay? Then you need to go and open your compass, go on this point, because 0 is 0, we are going to transfer these points now. Okay? So the 0 is 0, you don't have to do anything. You go to the point, because if you use the scale, it will take too much time, it cannot be transferred very quickly. Okay, and the scale will not give you the right, because there is no such division over there. So you open it, put it on the 1, come over here, put it on the 1, and just mark it. Okay, this is how you transfer the distances from there to here. This point is 1 prime. Repeat it, go to the 2, come over here, mark the 2. 3, come over here, put the compass. That's why its labeling is very important. I see some students do not label it, they keep on doing it, and suddenly they put the 3 at 4 and 4 at 5 and 5 at 6, and then say, oh, where is I put the last point? And then there is no point back. So you need to make sure that you label it all the time. So you go to the 3, you see 3, mark it. So if you label it properly, you can save too much time. 4, you come to the 4, mark 4 prime. You come to the 5, you go and 5, mark it. You go to the 6, go to the 6. Okay. So what is going on between 3 and 4? If we have more division, we get the exact point. If not, we can approximate it. Understandable? Yeah. So what we need to do now, we go to the next level. What is that next level? Is dual. Dual is 60 degree. So what happened in the dual? Basically nothing happened in the dual. This radius, whatever the radius value over here, 0.6, should be the same radius over here so that the follower will not move at all. Okay. So over here, we write it something like this. This is also the point 6, and from 6 to 6, you must need to write on the displacement diagram that this is the dual period. Agreed? So we need to put the point 6 prime again. Let's say we have a 6 prime again. Now we'll come to the descent part. Okay? This part. We did the 6th division over here. We can do different number of divisions over here. Okay, for each part you are independent. But whatever the number of divisions over here should be the same number of divisions over here. Okay? And if it is a simple harmonic motion, then the same number of division on the circle. So what is the next part saying? What is it saying? Cam uniform velocity. Okay, so we have nothing to do with this circle because we use this circle part. Basically, it's a full circle. Okay, basically it's a full circle, but we use the half of it only. So if the second part is all simple harmonic motion, we'll use this. In that case, the clever idea is to use the 6th number of division. Okay, but now here we have to use another technique to get the uniform velocity. So it's up to us. We can make more divisions and we can make less division. If the angle is too high, 120 degree or something like this, then probably you can get more, you can think about getting more number of divisions. Okay, but just for the solution, we stick to the 6. All right, so we have 6. So this one is also your 0.6. This one is 7, 8, 9, 10, 11, and okay, because we did the 6th division, 1, 2, 3, 4, 5, 6 divisions. We'll do the same 6 divisions over here. 6, this is, that one is a 6 point. 7, 8, 9, 10, 11, 12. So from 6 to here, we have ID. Okay, and it's basically uniform velocity. So if you remember from your dynamics, in your dynamics you probably made this displacement curve and you derivate it, so you get the velocity curve, you derivate it, you get the acceleration. If you look at the displacement curve and then you look at the velocity curve, if the velocity curve is a straight line, it means it is a uniform velocity. Okay, so here we also use the straight line. So what we need to do, we need to join the first point. Okay, that's why this delta is very important, the first point and the last point. Okay, and each point will give you this. So this one is your 7 prime, 8 prime, 9 prime, 10 prime, 11, and then 12 and 12 prime are the same point. Why this is a straight line? Because uniform. We'll do the two cases only. In the book, there are certain cases like uniform acceleration and so on and so forth. But we just try to understand how this whole process for creating the cam. So we are not going for the uniform acceleration. Okay. So we have only two cases: simple harmonic motion and uniform velocity. If it is simple harmonic motion, you take the reference from the circle. If it is a uniform velocity, you take the straight line. If this part is given as the uniform velocity, what you do? You do 0, 6 and join the straight line. And you get the reference points. Okay? Understandable? So it's your job to read the question properly, get the right input data, and from that input data, you can get the value. So once we get these points, what we need to do? Transfer it again, and before transferring, we need to extend these lines. So from the center, 7, move out. 8, center, 9, 10, 11, and probably 12 will come over there, so we don't need it. Okay? Again, you need to transfer those points very quickly. Labeling is very important. If you do not have a label, you probably get confused which point to measure it. The best technique is compass. You open it, go to the 6, extend it, come to the 6, and go. 6 is already there. You go to the 7, open it, so you get this 7 prime. 8 to 8, 9 to 9 prime. Come over here. 10 to 10 prime. So this is your 10 line. And 11 to 11 prime. And 12 will come exactly over here. Okay? So this is done. This is our profile is done. All we need to do is to join all these points. So you can join these points through French curve or through something else, or freehand if you do not own a French curve. Okay? So I'll try to join them and see what we'll get. Should be very smooth, but so this is our cam. Which cam profile? Which will follow this. If we have more points, we get more points to use it, okay? But since you have done this engineering drawing, your curve should be much better than mine. And you should not be like this. It should be very smooth curve all the way to the point. Okay, any question? I'll repeat everything, but till now, do you have any question?
About these, how do you draw this circle? The 150, just degrees, regular degrees, yeah. Because I saw it here, it's not here because no ruler.
No, it's pretty much, this one is 150. So if you get 90 degree, okay, something over here is like 120 and little bit more than, so 150. Yeah, you have to measure it with the protector.
So, like
Yes, all the angles are measured from this line. So let me
and left side.
yes. Because the cam itself is like a coin. You can see like this, you can see like that. I think this information is mentioned somewhere over here. It's like moving clockwise or anti-clockwise, but it doesn't matter. You can draw it from that side clockwise direction as well. But if you draw it anti-clockwise, we have all these problem we solve it assuming it's going in this direction. But the cam itself is just like a coin. You can look like this. You can whenever it is manufactured, okay, it looks like. And then in the assembly, there is some different issue. Okay, so it's up to you if you want to make it from this direction or if you want to make it from this direction. Better to be anti-clockwise so we all are on the same frequency. Okay. Yes, once you start measuring the angle from here, 150, then 60, then 100, and whatever is left is the 12. This is RC. If you remember, I write it over here. This one, this angle, this one is your RC. Okay, so it's the minimum radius that can fit into the cam profile. Okay. All right, let me quickly read the question again and then I'll quickly run through it again. Draw a cam profile operating a knife edge follower with a lift of h 30 mm. The cam raises the follower with a simple harmonic motion for 150 degree of rotation followed by the period of dwell for 60 degrees. The follower descent for 100 degree rotation, 150, 60 descent for 100 degree rotation of the cam with uniform velocity. Again followed by a dwell period. So once it does, and then there is a dwell period, which we calculate is roughly like 50 degrees. Even if you don't calculate it, whatever leave is the dwell period. The cam rotates a uniform velocity of 120 degree RPM. So there are some formulas are given. You need to use that RPM, etc. for calculating the maximum velocity and maximum acceleration of the follower during the lift and the return. For drawing, how do we start? We start with drawing the displacement diagram. Okay. For that matter, just to save your time, I draw the displacement diagram here. Now, what is the problem with this displacement diagram? Because you can see it's 30, and over here it's written h. In this case, this h is 30, but if you measure it, it may not be 30. Because what happened with this printout, it changed the aspect ratio and all these things. Okay, but just to save our time, just to practice this part, whatever is mentioned like 32, 35, 28, you just assume this h, whatever the height it is, and draw it accordingly. Okay, just to save your drawing time. Okay, if I were at your place, I can draw this whole picture in like 1.5 minutes. Okay, and you can do it as well. Very quickly you can draw this thing. But just to save those few 2-3 minutes of the students, I draw it over here. But the only issue with this drawing that it may not be exactly the same value. You see in the next question it's 35, 32, 28, and also sort of. Yeah, it doesn't matter. Okay. Next printout I gave you, it's maybe 31. Next printout I gave you, because it shrink accordingly. So once you get this, the reference is there. You draw the RC, the minimum radius. Okay. And then, because this is the case 1, which is knife edge. If you remember in the last lecture, we said that there is a combination of knife edge can be offset. This can be have a roller. Okay, so we'll go do the other cases later on. This is a knife edge in the same direction. So the center of rotation and the axis of the follower is in the same line. recording, otherwise I'll say something to you. Okay, it's in the same line. Because it's the same line, this is our case number 1. So once we draw this thing, we draw these phi A, delta 1, phi D, and over here we decided how many number of divisions we want to have it over here and how many number of divisions we want to have it over here. If it is simple harmonic motion, we need to use the circle. If it is not a simple harmonic motion, we do not need this circle. If both of this is uniform velocity, we do not need this circle at all. Okay? Once we draw this RC, minimum radius of the cam, okay, and then we have this division phi A, we decided to have 6 divisions, we divide it into 6 divisions. Okay, you can do the divisions very quickly through compass, or it's up to you if you want to use the protractor to measure the angles. Once you do 6 divisions, you come over here and 6 divisions. Take the reference, because this one is a simple harmonic motion, you need to take the references from here. 6 division here, 6 division here, same number of divisions, and same number of division on the circle. If you decided to have 8 division over here, then 8 divisions over here and 8 division on the circle. Okay, if you decided to have 10 divisions, then it should be same. Once you decided to the same number of divisions and you mark the point, then you need to transfer those points. So these 1, 2, 3, 4, 5, 6 are here. You need to extend these lines. Take the reference from 1 to 1, 2 to 2, 3 to 3, 4 to 0.4, and so on. Once you transfer all the reference points, then you have this dual 1. Okay, dual 1, because the dual means the follower is not doing anything. The follower stays there. And this can only be possible if the radius of the cam does not change. It stays there. So whatever is this, we have the same. So we draw the same in the displacement diagram, okay, and we label it accordingly. Then we have a dual, then we have this descent or going down. In that case, we have 100 degree, we already have 100 degree over here. Since it is not a simple harmonic motion, it's a different case, uniform velocity, so we can use a different number of divisions. Okay. We decided to have 6, so we divide this 6 over here and 6 over here. Because it's a uniform velocity, we draw the straight line from the start point to the end point, and we got all the references there. Once we get the references, we need to extend these lines, okay, and then measure it from 7 to 7 prime, 7 to 7 prime, 8 to 8 prime, 9 prime. Once we get all these displacement distances transferred over here, all we need is to join. Once you join it, the cam profile is complete. Okay, can you do it? You have 10 minutes now. Start doing it.